Hello! So in this video I'm going to run through the terminology surrounding quadratic functions, and then I'm going to move on to how the graph looks depending on what the equation of the function is. So first off, a quadratic function is something which is on this form, and it's important that a is not 0, because if a was 0 then the whole first term would go away, and then it's just going to be a linear function. And every time I graph one of these quadratic functions, the graph is called a parabola. So it can look like this, like the green one, or like the brown one. It can be pointed upwards or downwards. And we're going to run through different terminology aspects, so what things are called surrounding these parabolas. So first off, we have the point where it intersects with the y-axis is called the y-intercept. So the green's y-intercept would be this number, and the brown's y-intercept would be whatever the value is down here. Where the graph hits the x-axis, we call that the x-intercepts, or the zeros, because the y is 0, or the roots. Sometimes they're also called roots. And in this case, the green one has 2 x-intercepts. The brown one actually has none. So the brown one doesn't have any x-intercepts. And we're going to dive a little bit further into this because you have 3 cases. Either you can have 0 x-intercepts, or you can have exactly 1, or you can have 2. And then we also have something called vertex, which is here, is for the brown one, the top, like the maximum point here is going to be called the vertex. And for the green one here, the bottom point here is going to be called the vertex. And final thing is, if I draw a vertical line through the vertex, that's called the axis of symmetry. And that's because the parabola is symmetric around that axis. So every time I go to one point, I'm going to have another one mirrored in this line on the other side. So every point is lying symmetrical about this axis, and that's why we call it the axis of symmetry. Right, so now we're going to move on to how the graph works depending on what the values of a, b, and c are. And then at the end of the video, I'm going to show you one extra thing called delta, which is the discriminant. We'll go back to that. So first off, if a is a positive number, then the parabola will look like this, pointing upwards. And you can see that if I make it larger, so the value of a is down here, I'm going to change that. If I make it larger, what happens is the parabola gets narrower. If I have a positive number close to 0, you can see that it gets wider and wider and wider. So the closer to 0 we are, the more wide it's going to get, and the larger the number, the more narrow it's going to get. But all the same, if a is positive, it's pointing upwards. If a is negative, then it's opposite, then it's pointing downwards. And again, if I have a negative number close to 0, then it's going to be a wide parabola. If I have a negative number that's a large value, then I'm going to have a narrow parabola. And of course, a cannot be 0, because if a was 0, then we would have a linear function, and then it's not a quadratic function anymore. So that's a. A tells us whether this points upwards or downwards, and how narrow or wide it is. C is actually the easiest one, because C is just where it hits the y-axis. That is the y-intercept. So every time I have it on this form, C is going to be the y-intercept. So in this case, if C is 1, then it's going to hit at 1. If C was 5, then it's going to intersect at 5. If C was -4, well, then the graph is going to intersect at -4. So C is just the y-intercept. So that's nice and easy. Now the final thing, B here, that is, if I look at the y-intercept, then I can see B is going to tell me actually the slope of the graph just here. So it's going to tell me whether the graph is increasing or decreasing at that point. So at the point where it hits the y-axis, B tells me whether the graph is going upwards or downwards. So for instance, if B is a positive number, then when I cross the y-axis, the graph is going upwards. If B is a negative number, then when I cross the y-axis, the graph is going downwards. If B is 0, then I actually get the vertex. Then it's symmetrical around the y-axis. that is because if it's the vertex, then it's neither increasing or decreasing. Then it's just horizontal at that point. So A determined whether the point upwards or downwards. B was when I cross the y-axis, am I going upwards or downwards? And C is just what is the actual value I hit on the y-axis. If C is 0, then I cross at 0. Right there. Now, final thing is we have solved what was called quadratic equations, which is the same thing, just when I put the whole thing equal to 0. And to solve that, we've seen that we have this quadratic formula. So based on a, b, and c values, I could calculate the numbers x, which solve this equation. So we're going to introduce something new. We're going to introduce all of this under the square root sign. We're going to call that delta, which is called the discriminant. So we're going to do this in 2 steps. First, we're going to calculate the discriminant, and then we're going to calculate the same formula, just with this number inserted under the square root. So instead of doing it all at one time, I'm going to do it in 2 steps. And that's because when I have quadratic functions, the discriminant is an interesting thing. So we have a, b, and c, which we just went through their meanings. But for quadratic functions, so instead of having a quadratic equation, I have a function. Then the discriminant actually tells me I have 3 cases based on the sign of the discriminant. See, if the discriminant is a positive number, then the square root of a positive number is a positive number. So I'm going to get this plus minus a number, and that's going to give me 2 solutions. If the discriminant is 0, then the square root of 0 is just going to be 0. And plus minus 0 is just nothing happens. So I just get one solution, which is actually negative b over 2a. And finally, if the discriminant is negative, well, then I have a problem, because I can't take the square root of a negative number. And that means I don't have any solutions. So there is no way to find an x that satisfies this quadratic equation. Graphically, for quadratic functions, that means we have these 3 cases. If the discriminant is a positive number, then the graph will cross the x-axis twice, because we had 2 x-intercepts, right? And it doesn't matter if a is positive or negative. It's always going to cross the x-axis twice if the discriminant is positive. If it's 0, then we had one solution, and that actually means that the one x-intercept is going to be the vertex. And the final thing is, if the discriminant is negative, then we did not have any solutions, and that means that the parabola does not cross the x-axis. And that's it for now. Have fun. Hi hi.